Hi everyone. In this video I'll explain to you how to check your model using the AOS GUI. So we already documented our robot project using an environment file, and we are running on the same example from the other videos. So we have a single skill called navigate, so we have an SD file to describe it and an AM file. And now we want to see that the model we created is working as we expect. So how can we do it? Okay, so the first step is we will run the AOS Web API. Okay, it's running. The next thing is we will run the GUI. We have the run GUI bash, okay, and in here we have the command that is running the GUI. I'm just going to copy and paste it. Okay, good. Now, my recommendation to you is to start the AOS Web API using the command line and not to use the GUI, even though the GUI can shut down and start the server, but don't use it. Okay, now you are clicking integration request and initialize project request. In here there is the PLP directory, and you are giving the directory to your documentation. Okay, so our example is in the AOS experiments tutorial paper example. Okay, and now we will go down, and in here manual control we will say true, because we don't want the robot to work autonomously. We want to control it, to tell it which command to execute every time. And in here we can control the amount of particles for the belief state. Let's leave it as is. And this field is important. It is telling us how many particles, how many samples of the state will be saved inside the AOS database, and we will say 50. This will give us the resolution on the distribution, how much our approximation will be good, on how we can look at the distribution. The distribution itself, it uses in here 50,000 particles, but what we can see in the GUI, it's only going to be from these 50 particles. Okay, so this is important. And in here is internal simulation. It's telling us if we actually want to operate the robot or just to simulate using the solver without actually activating the robot. And this is easier when we want just to debug our model without applying it on the robot. So we will keep it on true and send the request. Okay, so we took it a bit of time because it's building the project, and in here we can see 100% build target, which means that there weren't any errors, and we can also see the list of files, of documentation files that were loaded. Okay, so after we run this, we are clicking back, and again, and in here we are clicking on the get execution outcome request, and we are writing the number of particles we want to see in the belief state. So the AOS, it saves 50 particles inside the database, and now we can write how many particles we want to see in the GUI itself, how much it will ask from the AOS to give it. So even though if we will run, if we write 100 or 1000, the maximum is 50, but we can write less than 50 if we want. So I'm writing 50 here. In here there is an option to write a script that will visualize the belief state using an image, but we won't go through this now. Okay, so we just write 50, send request. Okay, and in here we can look at the possible actions. Okay, so in this example you have 3 actions. Action ID 0 to navigate to location 1, and action another action to navigate to location 2 and 3. Okay, so we can select the action we want, and if we want to end the process, we will just send this terminate action. Okay, so let's navigate to location 2. Okay, I'm double clicking it. Okay, and we can see the logs here, and the AOS will perform this action, and we can return to simulated states. Now in here we can see 2 things. One is the simulated states. It simply selects a single state from the initial belief, and it's saying this is the state of the world, and then we can look at the state which was sampled. It's one of the possible states in the initial belief, and we can click the next state. Okay, because we told it to perform an action, and we can see how it changed. Okay, so if the robot location was in location 3, after we perform the action, now it's in location 2. Okay, and here, and after we are clicking next until the end, we can go to manual control and select the next action. Now okay, so in here we can see how our model is acting based on a single state that this is called the simulated states. Okay, when we are clicking on the execution outcome tab, in here we can look at the robot's belief, because we are dealing with uncertainty regarding the current state. Then we can see what the current state the robot is thinking. Okay, so let's go to the previous until we can't go anymore, and we can see the initial belief, and we can write in here in the filter, we can write robot location discrete. Okay, in here we see the probability to be in each one of the possible locations. Okay, this is our initial belief. Okay, so when we were in simulated state, we only saw a single state which was sampled, but this is the robot's belief, and it will act according to this belief, and we can see how what we represented eventually, what's the outcome when we are running the AOS. So this here is the initial belief, the code we wrote. Okay, so we said state robot location discrete. We are sampling 50% of the time. We are giving it to be in location 1, and we can actually see that it's close to 50%. Okay, on location 1, and if it's not on 1, then 20% of the time, Bernoulli 0.2, then it will be at location 2, otherwise it's in location 3. Okay, so let's look at the GUI, and we can see that we have more in location 3, so this it looks reasonable. Okay, so we can filter any one of the state variables. Okay, like .x or any other state variable, and to see it, and then we can continue and selecting the next state, selecting the next action. So let's navigate to location. Okay, now after we navigated to 2, so it's saying that it's very reasonable that it's in location 2, and it's possible that it's lost its orientation. Okay, so now let's navigate to location 3. Okay, discrete destination 3, action ID 2. Okay, and let's go in here and see. Let's look at the robot's belief, and now we can see that it's thinking that it's in location 3, and there is an option, maybe it lost its orientation. And let's look at the simulated state. Okay, we see now it's in location 3. Okay, So this gives us a very simple way to check that our model is doing what we think, at least roughly, okay? And in the belief state, we can see it even more accurately using a lot of particles to see the distribution. Once we finished it, maybe we want to start it again. So it's very important to do the termination action, okay, to end this process, and then we can close the window, and then we can do it again. We can go to initialize project request, and it will save us the last request. Okay, you see the same. All of the fields are the same as we did the last time. Just to send again the request, and we are waiting until it's building it and everything. Okay, and now we can check again to see, because everything here it's probabilistic, so maybe we want to do a double check on things. And again, we are writing the get execution outcome, and now let's write 3. Okay, even though we saved 50 particles in the database, just to show you, if I'm writing 3 now, I will get a very rough estimate of the current belief. Okay, so let's navigate to location 3 and click execution outcome. Next. Okay, so now it's telling me it's 100% that we are on location 3. Now if I were to use 50 particles, then I would see that there is a slight chance that it's lost its orientation. Okay, so that's it about debugging using the GUI, checking that our model, the model we wrote, is acting as expected.